Hello everyone, my name is Daniel, and for my demonstration speak, I'm going to be talking about the sine rule. We're going to be covering a little bit of basic trigonometry and some of the terminologies and how can we apply this rule to an example of an static force. So, in order to better understand certain problems involving forces, it is necessary to use some mathematical ideas from trigonometry, specifically the study of triangles. Most people are introduced to trigonometry in high school. There are many complex parts of trigonometry, but we will just stay put with a general idea of a triangle. So basically, a triangle is a closed shape with three sides and three internal triangles, as we can see right here in the slide. The sum of each of the angles must equal 180 degrees. You will find various shapes of triangles. One of them is the right triangle, which is a triangle that has a 90-degree angle right here in this area, and the long side in front of it will be called the hypotenuse. In trigonometry, the law of sines, or the sine formula or sine rule, is an equation relating the length of the sides of a triangle to the sides of the triangle. As we can see right here in the picture, we have the side A divided by the sine of angle B will equal side B divided by the sine of angle B. Therefore, side C divided by the sine of angle C will equal the one that I mentioned earlier. The law of sines can be used to compute the remaining sides of a triangle. This is when you know two of the angles and one of the sides. You must remember that you need to have some known sides or angles in order for you to be able to utilize this equation. Now, this example has a vertical force. This vertical force is acting at this point right here, and it has two components that will go from this point to right here and from this point to here. They are called FAB and FAC, which represent components from this main vertical force. Now, this force right here is a known force in this exercise. Its value is going to be 500 newtons. There are some steps. Specifically, I'm going to mention 4 steps that we need to follow in order for us to be able to utilize the sine rule and to be able to get the unknowns that we want from the exercise. Right now, we are looking for FAB and FAC, which are 2 unknown forces that we have. So the first step is that we need to arrange the given forces in a way that creates a triangle, which is called a force triangle. What we're going to do is that we're going to move force F all the way to B to connect FAB to FAC, and we will create a force triangle. Now, we already know 2 of the angles. If we sum the remaining 45 degrees from this quadrant right here to the 30, we will get the 75 degrees. This 45 degree is exactly the one from this side over here in the main free body diagram. Why? Because we know that in a quadrant we just have 90 degrees. So if we sum them up, we're gonna be missing 60 degrees to get the 180 that we need inside of a triangle. So that will give us all the 3 angles inside of this triangle, plus the known force that we have. So that will let us apply the sine rule. The second step is identify the known side, which in this case is an acting force, which is this side right here, that F equals 500 newtons. The third step will be identify the direction or the angle that goes with this known force. In this case, it's the 75 degrees, which is the angle right in front of the known force. Now, the fourth step is to apply the sine rule. As I mentioned earlier, we will have side A divided by the sine of A equaling side B divided by the sine of B equaling side C divided by the sine of C. Now, we will substitute the values that we already have or that we know to this equation. We will have FAB with its front angle. We will have FAC with its front angle, which is 45, and we will have F with its front angle, that it's 75. And utilizing what we know, we will have the FAB divided by sine of 60 will be equal to F divided by sine of 75. And we already know that this F is 500 newtons. So if we isolate for the unknown value, which is FAB, we will have that FAB equals 500 newtons times sine of 60 divided by sine of 75. That will give us a force along AB of 448.29 newtons. So applying the rule that I mentioned earlier, we were able to get that unknown force, which was FAB. Now, continuing applying this fourth step, we are able to get the other unknown force that we have, which is FAC. Now, we do exactly the same thing. We grab the value that we know, which is the 500 newtons, divided by the angle that's in front of it, which is 75 degrees, and that will be equal to the unknown force divided by the sine of 45. And as we isolate FAC, we will get a value of 366.02 newtons. Exercises like this one are very helpful in the understanding of how to analyze a static force in a specific point. This is a really good example of how trigonometry and physics aid in the understanding of an engineering analysis. So, thank you.